What we'll be covering in this introduction are some very basic fundamentals of redshift to get you started. I'm not going to be covering anything super specific, but rather I'm going to show you a few ways on how to think about redshift shaders so that when it comes to the more complex stuff down the line, it'll be easier to understand and you'll know kind of how to build them a little more intuitively. So let's get started. All right, so first things we're going to do is just create a little mode text setup. Text is really conducive to figuring out how shaders work and how they interact with one another because there's a big variety of edges, curvature, and just general variation that'll allow us to very nicely kind of ID how a bunch of these shaders and textures work and project onto geometry in the default setting. And so we're going to get right into this and go ahead and make yourself a redshift material. And you'll see the node graph will pop right up, and we're going to drag the material onto the object. We're also going to make an area light, and with this one, read in your favorite HDRI. I'm going to set the gamma on this guy to approximately where I want it. And this should set us up nicely to experiment with the node graph a little bit and kind of start seeing how these shaders react. The first few nodes I'm going to introduce you to are the texture node and the noise node. So go ahead, drag your noise node in there, drag your texture node, and now we are, let's start with the texture node. We're going to go in there and I'm going to choose, I got a grungy metal here, just general map overall that I'm going to use for this. And I'm going to take that node and connect it. If you drag to the blue, it'll auto pop, and then you'll see diffuse color, and I'm going to plug it right into diffuse color, and you'll see the viewport update pretty quickly. You can see that on the inside there is some tiling like you would expect. It is going to just apply it in UV space by default, and this should pretty successfully match with Cinema's default projection. So you can see on the material it says UV mapping, and you throw it in cubic and you get the expected result. So any texture that you have read in that isn't itself either clearly defined as a camera projection, a specific UV map, or whatever will inherit the setting of the tag itself unless you specifically specify, in which that'll override any setting you have in the tag itself. Next, we're going to plug in the noise node, and you'll instantly see that the texture we read in disappears and gets subbed by black and white noise. Has a few settings, and if you change it to turbulence, you'll see it's pretty dramatically different, and at any point in time we can toggle it back and forth between the noise and the texture. And you'll see it does update pretty quickly. I'm going to sneak a little bonus in here and drop a triplanar node in here. You saw that I switched it to cubic earlier, and what triplanar is essentially an improved cubic where it will auto blend the edges for you. We're not going to go into super detail, but this is an example of taking a texture, using a projection mode within redshift, and that overriding the tag projection. In addition, we're also going to drop a ramp here. This is another one I'm going to introduce you to. If you ever wanted to throw a levels on something, this is pretty much the most reliable way to do it. Set that to Alt so that we can get the input from it, and then go ahead and connect that to the diffuse input. So we're going to explore noise and ramp at kind of the same time to cover a lot of ground pretty quickly here. So you'll see under the noise settings, there's a bunch of sliders that you can toggle through. Go ahead and zoom in, and so we can really see what's going on with this, because some of these details are going to be very fine. You can set the complexity down, and you'll see it'll be more brute force, more larger, and then as you up the complexity, it'll have increasingly finer subdivisions, and amplitude and frequency gain can be adjusted to taste. And this is very much figuring out kind of the complexity of the noise you need, and this is all very much done to taste. So experiment with this a little bit and kind of get the feel of how this is all interplaying with each other. And when we go over here to the ramp node and crush it all down, it kind of reacts how you would expect levels to react, and that is essentially what you're doing. If you use any applications that have a histogram or a levels, essentially what you're doing is recrushing the values and setting the in and out points to different ranges, and the ramp will react the same way to noise just as it does to normal textures. So we've got quite a few nodes that we went through very quickly, and I'm going to throw another good one at you with a little bit of minimal explanation, but just because I feel it is very important, and that's going to be the curvature node. So go up to your Find Nodes, type in curvature, and drag it on in. So if you connect the output of the curvature to the diffuse input, you'll see it kick over and you'll instantly get a little bit of like an edge finding result. So if you go to the first thing you see over here, radius, and crank it out, you'll see that that radius of detection essentially is expanding and bleeding out. So I think this is a good point to kind of talk about more generally how we can handle these maps essentially that we're building in Redshift. And we're going to kind of change the environment around a little bit here to kind of be more direct one-to-one with the data that we're creating and how to handle it. So I want you to go ahead and make another dome light. In this situation, though, it's going to be pure white, and we're going to set it to not to be visible in the viewport. And as soon as you turn off the background, you'll notice there's some extraneous light boost in the text. So that is the reflection from the HDRI. So go into the material, and we're going to turn that reflection to 0, because what we really want to see is the direct results of the maps we're creating with our texture, noise, and curvature, and the color values that we're essentially creating that we're going to be manipulating down the line to create masks and use as complex layer masking. So flipping through curvature a little bit, you can see that there's a variety of modes that give us quite dramatic differences in shading, but we're going to go back to convex, the original one, and you can see in the remap there's some additional settings that allow you to pretty drastically change the look and the gain of how curvature is calculated on the model you have it on. Now, this is where we can start getting into some cool combined shader stuff, is that you can pretty much plug anything into anything in Redshift. So just for shits and giggles here, let's plug the resulting of the noise ramp into the gain of the curvature and see what we get. Immediately, you'll see that it does take a pretty drastic turn. If you go back into it and adjust the bias a little bit, you'll notice that anything you do not have plugged in with another input, you still have full control over, but the gain is locked out, because now we are controlling the gain with the black and white map that is the RS noise. And that is a good segue into how we should be thinking about the kind of maps we are creating, because essentially what we're doing here is we're creating black and white maps from 0 to 1 that we are using to mask off and create selections that allow us to modify shaders in ways we like. Just like when you export roughness maps or reflection maps from any application, you're going to get a black and white mask, essentially, where black is a value of 0, where you would have no reflections and no bump, or straight black color, and white would be full on. So knowing that all we're doing is creating black and white maps with a variety of utilities that can then be recombined and mixed together in a variety of ways, we're going to go ahead and backtrack a little bit back to turning all the beauty lighting on, and we're going to try and recombine a bunch of these in bunch of cool ways and kind of show you very explicitly how we can use any map we create on any channel and repurpose it for whatever purpose. So we're going to go ahead and switch back to the original dome light that had our beauty on it and turn back on the reflections. So now we have more of a standard material. I'm going to go and take that triplanar and plug it into the diffuse instead. But just as we used a ramp to control the noise, we're going to use a ramp to control the resulting texture that we've read in here. Make sure to toggle it to Alt, because that's how you get that input, not a UV-based gradient. And we're going to go ahead and levels this guy down a little bit, and you can immediately see that the results are pretty dramatic. And knowing that we have a black and white map that all we're really creating, I'm going to use that as a reference for reflection weight. So I'm going to use that black and white map that I just previewed in the diffuse color, and I'm going to plug it into the reflection weight and use the black areas to knock the reflection out and the white areas to make sure that we still have a full power reflection visible. And that's a pretty interesting result, a little crushed, so let's soften that up and you'll immediately will start getting some more reflections back. Inspecting this guy, you can see it has a total result on all sections of the model. Looking at the top here and trying to get a little more oblique angle, you can see that the material we're using and projecting from black to white is being used to mask reflection weight. Let's get a little clear view of this and just swing your HDRI around to kind of get a little more highlight, and now it becomes extremely clear where the image is being projected and where those black and white results are that are masking the reflection. So since we're deriving some data from the curvature and topology of this guy, let's make this model a little more interesting. Just going to go ahead in here in the mode text and add some fillet caps, a couple subdivisions, kind of get that dialed in, constrain it. And so while I readjust this lighting to kind of get some light on the front face of these, the last thing we're going to do is just plug a bump node in here and reuse one of the assets we've created, because that is one of the strengths of using node-based systems like this. So go ahead and get your bump map and just take that triplanar material and plug it into the texture input. And when we plug it into the RS material, you'll see it is in overall, and there is a bump input. So the first thing you'll see, it'll look pretty broken, and that's kind of because it is. We'll need to dial down the height of this and kind of get it within a range that looks physically acceptable. And let's immediately drop that height scale down to like 0.1, and that's a little much. Let's go down to a little lower, and that is starting to look a little bit more in line with what we would expect out of a situation like this. Now, if you're new to node-based compositing, one thing that may not seem initially intuitive is that you can take the outputs pretty much from any point within the pipe and reuse them and kind of create complex networks on how you interconnect and at what point you reference certain elements within your shader tree. So if we go back in the bump here and kind of play around with it a little bit more, let's actually take that triplanar prior to the redshift ramp and plug it in, and you're going to notice a pretty drastic change to the bump map overall. And obviously you can torture and abuse this to your personal taste and crank it up or down however you feel like using it. While this tutorial doesn't have a specific end goal or end target that we're creating, the main goal of it was to provide you a rough understanding of how we're generating maps and how they react in redshift, such as the noise we created that we plugged in the diffuse that we ended up using as the gain seed in the curvature, and understanding that anything that we can plug into any channel where we can see the color values, what we're essentially seeing is the black and white maps that we are generating that are being used by redshift to interpret how to handle the individual components of the shader you're building. So I hope this gives you a good baseline understanding before we go into the next tutorial, which will involve a much deeper dive into color layering, material layering, and using some of the complex user data functionality within Redshift to drive some really creative shader solutions for more complex problems.